Okay, so this is independent probability. Independent probability is when you have two selections and one of them is not dependent upon the other one. And what makes it not dependent upon the other one, or what makes it independent, is that once you pull the first time, you replace it and then you pull the second time. So this is asking what is the probability of selecting a blue ball, I'll say, replacing it, and then selecting a yellow ball. So to do that, we have to determine the total amount of balls, or whatever these are, that's in there. And 6 and 5 is 11, plus 2 is 13, plus 7 is 20. So there's 20 total items of balls, or whatever we're using. So the probability of pulling a blue would be 6 over 20. And then the probability of pulling, and we're going to replace it, so we can pull it and put it back. The probability of pulling a yellow is 2 over 20. So to find this probability, the probability of this and the probability of this would be 6 over 20 times 2 over 20, which equals to 12 over 400. 6 times 2 is 12. 20 times 20 is 400. We simplify. That could be 6 over 200. We can even simplify that, and that would be 3 over 100, dividing them all by 2. So the probability of pulling a blue, then pulling a yellow, would be 3 over 200. Let's try another one. The probability of pulling a red, then pulling a blue, probability of replacing it. So the probability of pulling the red is 5 over 20. 5 is the amount of red, 20 is the total. The probability of pulling the blue is 6 over 20, because we replaced it, and that would be 30 over 400. We can simplify that by dividing the top and the bottom by 10. It'll be 3 over 40. So the probability of me pulling a red first, then a blue, is 3 over 40. All right? So the thing that we need to remember when we're doing probability for independent events, that means that we're going to replace whatever we pulled the first time. All right?